So learning objective 10 is to describe the ways to interpret a graph. So these interpretations are always done on an XY scatter plot. So there's 3 ways to interpret a graph. First way is to find the slope of the best fit line. Always pick points on the best fit line. Do not pick data points. We're looking at the overall trend. So we're not looking at the data itself. We're looking at the overall trend within the data. So whenever we do the slope of a best fit line, we want to pick points that are on the best fit line, because that is going to give us a general idea of what we are looking at and what our trend is, our general trend. So let's say that versus time for balloon car. Always remember to have a title. So you want to have a title for any graph that you do. You want to label the X and Y axis. So again, like out of these two, my distance versus my time, the thing that I can control and the thing that I can kind of look at is my time. So my time is going to be independent. And then my distance is going to be the dependent. So distance would be here. And we'll say that this is in centimeters because I don't think a balloon car is going to be traveling meters long. And then this would be my time. And I would say that this is in seconds because I'm going to do it in seconds. So then I've got my X and Y axis labeled. So let's say that I have time, and I have a data table, and I have distance. And let's say that my time is every 2 seconds. So I've got 2 minutes is just what I measure. So then at 2 seconds, it was 2.2 centimeters. And then at 4 seconds, it was 3.5 centimeters. And then at 6 seconds, it was 5.9 centimeters, and then I had 6.2 centimeters, and then 7 centimeters. So then I'm graphing this on here, right? So my points are going to be black points that I have my line, right? And then I can create a best fit line on. Of course, if I had a ruler, this would be a lot straighter. I don't have a ruler on here, so I can't really do it straight. So ideally, you would use a ruler for your best fit line. So there's my best fit line, right? So then if I'm trying to figure out like, okay, well, what is my slope of this line? I would pick points that are not data points, right? And that are on the best fit line. So I would pick 1 point here and maybe like 1 point here because that's a pretty good point right there. Okay. And then, of course, our slope, which is m, is equal to the rise over the run, which is equal to the change in y over the change in x. So now, if at this point right here, I would say that this is 5 and probably about 6.5. And then this point is about 2.5 and 3. And then I can do my slope from this. So then 5 minus 2.5 over 6.5 minus 3. And that's going to give me a number. So I've got like, again, 2.5 on the top because 5 minus 2.5 is 2.5. And then 6.5 minus 3 would be 3.5. So then if I calculated this out, if you calculate it out, so 2.5 divided by 3.5, and this is what I'm always going to ask you to do, is calculate this number out. This number represents something. So if I'm looking at distance versus time, if I'm taking my y-axis over my time, then I'm going to have centimeters per second, which is my speed for the balloon car. So 2.5 divided by 3.5 would be 0.71 centimeters per second. So then again, this is my speed. Okay. So that's one way I can interpret a graph. The next way that I can interpret a graph is called interpolation. Finding a point on the best fit line between data points. So for a question, you can say, how far did the balloon car travel in 5 seconds? So I know it's 5 seconds. Now, there's two ways to answer this question. One way to answer the question is by looking at the graph. And I would say that this is probably the simplest way that you can do this, just because the other way involves math. So looking at the graph. So looking at the graph, I would go to 5 seconds. So right here. And I would go up to 5 seconds. And then I would go over, and then that number would tell me about the distance that the balloon car traveled in 5 seconds. So this would be 4 seconds. So I'd say it's 4 seconds. The second way that I can add be using the slope, right? Because I've got 0.71 centimeters per second. This is a ratio. So I can take my time and multiply it by that number, and that's going to give me a number that would be close to my answer there. So I could use the slope. So 0.71 centimeters per second, and I would multiply that by 5 seconds. Seconds is canceling out. So 0.71 times 5 would give me, or 3.6 if I rounded that. And that would be centimeters. This shouldn't be seconds. That should be centimeters. So for 3.6, both of those are reasonable. Whatnot. If I probably if I had a straighter line, I'd probably get the 3.6 from the actual graph. So the last way that we can interpret a graph is by extrapolation. So extrapolation is kind of a little extra. So this is extending on outside of the data. We are looking at estimating a variable that's not within the graph. So an example of this would be, how far would the car be at 12 seconds? So I don't have a data point for 12 seconds, but I could probably predict where that might go. So again, there's two ways to answer the question. So I can, again, use the slope. So using the slope, I've got 0.71 centimeters, and I'm going to multiply that by 12 seconds. So centimeters per second, my seconds are canceling out. So if I take 12 times 0.17 is going to give me about 8.5 centimeters. And then if I look at my graph, so the second way is I can look at the graph, right? So I can extend the line out. Now, so I've got 10, 11, so this would be 12 here. So then I would go up, and I would extend this line out. So I would say it's probably about right there. So really close to 9, it looks like, or about maybe 8.6. So again, I would come back over here. So not quite 9, but not at 8 either. So I would probably say it's about 8.6 centimeters is what I would guesstimate from the graph. Again, this is another way to interpret. So like looking at the graph or doing the slope. Both of those are going to be giving me something pretty similar. And as you can see, they're pretty similar here in interpolation as well. So which of these interpretations is the least accurate? And I would say that the extrapolation is definitely a little extra, right? Which would cause him to be least accurate. Just because we don't actually know why or if the line is going to continue. So we don't know if the trend is going to actually continue. So who knows if the trend's going to continue or not, you know?